In this video, we're going to model exponential decay. It says a patient takes a medication with a half-life. Initially, there are 11 milligrams of the medication in the patient's system. After 70 minutes, there are 7 milligrams. After how many minutes will there be only 3 milligrams remaining in the patient's system? Round your answer to the nearest whole number. Do not include units. So we're going to use this exponential decay model where P of t is our ending amount, P of 0 is our starting amount. It says compounded continuously, or you can at least assume that because, the medication is going to be wearing like every second of every day. So it's going to be being lowered each second of every day. K is going to be the rate and T is the time. They give us some information here, but it's like two problems. So let's write these into two separate problems. Problem 1, they told us that initially there were 11 milligrams, so that means P of 0 is 11. It says after 70 minutes there are 7 milligrams, so that's P of t would be 7. They give us the time, which is 70 minutes. But what they don't give us is the decay factor. So we don't know the decay factor for problem 1. Problem 2, they ask us, after how many minutes will there be only 3 milligrams remaining in the patient's system? So let's write down everything that we know about problem 2. First of all, P of 0 is going to be the same. P of t, they tell us that it's going to be 3 milligrams, so we can write that as 3. They don't give us the time, that's what they're asking us for, and they still don't give us a decay rate. So you can see that we're going to find the decay rate for problem 1 because that's one variable we don't know. We know everything else. We find the decay rate here, and then we can use the decay rate to find the second piece. So let's start with problem 1, plug in what we know. We have 7 equals 11 e to the kt, so t is 70, so it's 70k. We can isolate the exponential by dividing by 11 on each side. So we get 7 over 11 equals e to the 70k. We're going to take the natural log on each side. When we take the natural log on each side, we have a log law right here. This is log base e of e. Log base e of e is 1. We can also use the power rule for logarithms, which means we move the 70k to the front. So if we do those things at the same time, this cancels to 1 and the 70k comes out front. So we have natural log of 7 over 11 is equal to 70k. Then we're going to divide by 70 on each side. And k is going to equal, we're going to plug that in the calculator, natural log 7 divided by 11 divided by 70 gives us a pretty long decimal. I'm going to leave this in the calculator and use this for the rest of the problem, but for algebra purposes I'm going to write down a simpler version, so I'll just round it to 6.5 here and then use this as I do the algebra. So that means that we have negative 0.0065 for the k value for each of these. For problem 2 then, let's fill in our information, use the same model. We have 3 equals 11 e to the kt, so that's just k times t. We don't know t, so we're going to write negative 0.0065 t. We're going to divide by 11 on each side to isolate the exponential. So we get 3 over 11 equals e to the negative 0.0065 t. We're going to take the natural log of each side. Natural log of 3/11 equals natural log of e to the negative 0.0065 t. You can see we have a log law here. Log base e of e is 1. We can also use the power rule for logarithms, which states that we can take the exponent and move it to the front. So this will cancel to be 1. The exponent comes to the front. We have natural log of 3 over 11 equals negative 0.0065 t. We can now divide by negative 0.0065 on each side. And that's going to give us t equals, let's plug that in the calculator. Remember, I'm going to use the whole version of this denominator, so I'll use this version right here in the calculator. So I'll say natural log of 3 divided by 11 divided by, and I'll bring that answer back and use the whole number. And it tells us that our time is 201.22, but it says round to the nearest whole number, so we're just going to say 201 because it rounds down. 201, and we're talking about minutes, so it's 201 minutes for this medication to go from 11 milligrams down to 3 milligrams.